Hey guys, so today we're going to talk about rational functions. And so we've talked a little bit about rational functions in our parent function discussion. So our parent function for this would be f of x is equal to 1 over x. And so we're going to have the conversation this week about like things being in the denominator, things being in the numerator, and what that means. And so here we're going to talk about terms that have things in both the numerator and the denominator. That would be a hole in your graph, there's a gap in your graph. Anything that's in the numerator, a term, that would be an x-intercept, and anything that's in the denominator, that would be a vertical asymptote. So let's look at a picture of like what is a hole, what is an x-intercept, what is a vertical asymptote visually, and then we'll come back and we'll talk about like what are these three things and how do we write them. So here we have a graph of a rational function. Rational functions kind of can be challenging because they can look lots and lots and lots of different ways. And so here, this would be a hole. You might also hear me or Coach Clayton, when you get to calculus, talk about a removable discontinuity. And so all that means is it's discontinuous, meaning it's broken, but it's a removable one. So it's like, I can take this out, but I can also put it back in. These discontinuities here are like big gaps. It's like, I put a brick wall here, and you can't just rebuild a brick wall real quick. This is like, I can just like put a little grape here and fill that hole. I don't know, random things. Okay, so this is a hole. Or a removable discontinuity. These lines here and here are vertical asymptotes. Okay, and so both of these things, types of things, vertical asymptotes and holes, are things that are undefined. Okay, and the reason they're undefined is because the denominator is equal to 0. Okay, and if you remember, your denominator cannot equal 0. We talked about that when we talked about domain. So like if we were talking about domain here, x equals -5 would be left out, x equals -2 would be left out, and x equals 1 would be left out, because all three of those places, there's something in the denominator that's equal to 0 at those points that's causing the whole function to be undefined. And so these things are happening in the denominator. The whole also happens in the numerator. So if we go back here, your whole is something that's like, I'm going to divide this out. It started out in the denominator, so it's going to be undefined, but it's also something that's going to be divided out. And so in order for it to be divided out, you have to have it in the numerator and the denominator. And then your x-intercept is where it's going to cause the whole thing to equal 0. And so that's your numerator. And so this is more like when we were talking about factoring with quadratic functions, we set this equal to 0, and that was where my x-intercepts were going to be located when we were factoring. So here, we only have one x-intercept on this particular graph, and so that is going to be at 0. So using what we just talked about here, the holes and the x-intercept and the vertical asymptote, we can take that information and we can write the function for this. So here, I know that my x-intercept, which is at 0, so you could write this as x minus 0, or you could just write it as x. And so that's how we're going to pretty much write this from here on out, okay? We're just going to write it as x, and so that's going to be in the numerator. I also have a hole, and that is at x equals -5. And so when I'm looking at this in terms of factors in my equation, this is going to be x plus 5, because what's happening here is I set this equal to 0 and I set this equal to 0 and solve for x. That's going to cause that to be -5. So the number that's getting plugged in here, 0, or the number that's getting plugged in here would be -5 to cause that whole thing to be 0. So then in the denominator, because this is a whole, I have x plus 5. So that factor is going to come into play, and we can see that that factor is going to divide out. So we've taken care of this. We've taken care of this. Now we need to take care of my 2 vertical asymptotes. And so if I have 2 vertical asymptotes, I have 2 terms in the denominator. So I'm going to have one set of parentheses and another set of parentheses. So here, at x equals -2, another way to think about this is I want this to equal 0, and so I'm going to say x plus 2 is equal to 0. This is my factor. Because if I set that equal to 0 and solve, I end up with x equals -2. Same thing here. Something's happening at x equals 1. I need to move that over. So x minus 1 is equal to 0, and so this term is x minus 1. And so this would be a function that, or what could be the function for this graph here. There's an x-intercept at 0. There's a whole at -5. That's going to divide out eventually. And then we have 2 things left in the denominator as vertical asymptotes. So where you guys are going to land today is you're going to identify the things in an equation. And so most of your equations are going to be way simpler than this, but I'm going to do the tough one with you and then let you guys do the easy ones on your Go formative. So here, first things first, like let's identify anything that's going to divide out. So here I have an x in the numerator and x in the denominator. Those 2 things are going to divide out. I have an x minus 3 and I have an x plus 3. Those are different. These do not divide out. But I have an x minus 3 and another x minus 3. This one and this one will divide out. X plus 10, there's no other x plus 10s. And so here, nothing else is going to divide out. So here, I know that I have a whole at x equals 0. So that's the term that divided out. And I have another whole at x minus 3 equals 0, which turns into x equals 3. So I have a whole at x equals 3, or x equals 0 and x equals 3. Now, once I've divided things out, I can deal with the numerator. Anything left in the numerator is an x-intercept. And so I'm going to take x plus 10 and set it equal to 0, that factor. And so x is going to equal -10. But it's an x-intercept, so it's really just a coordinate. And so when I graph that, it'll be -10, 0. And so there's my x-intercept. Taking care of this one, and now all that's left is the denominator, and so these are vertical asymptotes. And those are going to be at x plus 3 equals 0 and x minus 7 equals 0. So when I solve this, I have x equals -3 and x equals 7. And those are my vertical asymptotes. And so all you're doing today is just identifying these 3 things. There's 2 more things that we're going to identify, y-intercepts and horizontal asymptotes, but we will get to that later in the week. All we're doing today is identifying wholes, x-intercepts, vertical asymptotes.